All right. So what I want to talk about here is surfaces of revolution. And this is from 11.6. So 11.6 surfaces of revolution. Okay, not to be confused with last year in Calc BC when you did volumes of revolution. You took a curve and you were revolving around the x-axis or the y-axis, and you used cylindrical shells or you used discs or washers to find the volume of a solid. We're not doing that, but it is similar. We're taking a curve and we're revolving a curve around the axis, either the x-axis, the y-axis, or the z-axis. And then what we're doing is we're finding an equation of that surface, okay? So a quadratic equation of that surface of revolution, okay? Not necessarily always a quadratic equation, but you'll see what I mean. So there's three cases. Case one is you have a curve and you're revolving it around, let's say, the x-axis. Okay, so if you revolve a curve around the x-axis, your cross sections of that curve perpendicular to the x-axis will be circles. So your equation is going to be y squared plus z squared equals your radius squared, but your radius has to be a function of x. Okay, and I'm going to draw a picture of that so you can kind of visualize what this means. There's your x-axis, your y-axis, and there's z-axis. So if you're going to take a curve and revolve it around the x-axis, it has to be a curve either in the xz plane or a curve in the xy plane. Okay, so let's say we have, I don't know, some curve that kind of goes like this in the xz plane, and you're going to revolve that around the x-axis. Okay, so you get kind of a symmetric drawing over here, and this curve, okay, and this will be your surface. Now notice it's not a solid, it's just a surface. So it'd be like the outer shell of, let's say, a bell. This kind of looks like a bell, okay? And these cross sections perpendicular to the x-axis will all be circles, where your radius is going to be this distance, okay? Or the z value of the function if your function's in the xz plane. Or if your curve was something in the xy plane, it would be the y value of your function that came out to about here, okay? And that gets revolved around. So you've got y squared plus z squared equals your radius squared. That's the equation of each of these circles. Now notice as x changes, those radii change, and that's why you get something that's a surface, not just something that's in a cross section of the surface. Second form is a curve revolved around, next let's do the y-axis. Okay, so if you take a curve and you revolve it around the y-axis, so that curve either has to be in the yz plane or the yx plane. Let's say it's in the yz plane. Let's say you've got some kind of a curve like this. Okay, and you revolve it around the x-axis. Now your cross sections perpendicular to the y-axis will be circles. Okay, and this radius of the function would be your z value with respect to y, or your x value with respect to y if your curve were in the xy plane. Okay, so the equation of this one is going to be x squared plus z squared equals your radius squared, but now your radius has to be a function of y. And finally, you're going to have a curve revolved around the z-axis. Okay, so if your curve revolved around the z-axis, you'd have to have a curve either in the xz plane or the yz plane. And let's say your curve looks like this. I keep drawing these bell or vase shaped things, and you revolve it around the z-axis. Okay, your radius is going to be the y value of the function as a function of z, or the x value of the function as a function of z. So you're going to get x squared plus y squared equals your radius squared, but as a function of z. Okay. Oops, I'm kind of getting off the page. Give you a second to catch up on that. And then we're going to do one example. I'll do example 5 from the book. Okay. So example 5 from the book, there's two parts. There's part A and B. Okay, so I'm going to move this up. I'll move this up to the side. Example 5 from the book. And where this is on page 804 of your book, if you wanted to follow along. Okay, so you have find an equation of the surface of revolution formed by revolving the graph of y equals 1 over z. So in part A, revolve y equals 1 over z, and you're going to revolve that around the z-axis. So if you're revolving around the z-axis, your cross sections are going perpendicular to the z-axis are going to be circles, and they're going to be x squared plus y squared equals your radius squared. Okay, this is the last one we're doing here. X squared plus y squared equals your radius squared, but your radius has to be a function of z. Okay, so you're going to have x squared plus y squared equals your radius as a function of z squared. Okay, and if we were to graph this, y equals 1 over z, first of all, I always like to graph this in the yz plane first. You know that looks like this. So now we're going to graph this in 3 dimensions. X, y, and z. And in the yz plane, it looks like this. And we're revolving that around the z-axis. So we're going to get something that kind of looks like this. Okay, we can't draw the entire thing. Remember, this goes up to infinity. This actually also will go out and keep going out, but it's going to look something like that. So our cross sections will be circles parallel to the xy plane. And the x squared plus y squared will equal your radius squared, which here your radius is going to be the y value as a function of z. Okay, which the y value as a function of z is 1 over z. So x squared plus y squared equals 1 over z squared. And you get x squared plus y squared equals 1 over z squared. Okay. Now let's do one more. Let's do part B. Similar problem. I made it a little bit more complicated. Find an equation for the surface formed by revolving the graph of, so we're going to revolve the graph of 9x squared equals y cubed, 9x squared equals y cubed around the y-axis. Okay, now I don't know what that graph looks like, so I'm going to graph it, and I'm just going to graph it on the calculator. You could plot points and kind of figure this out. I don't really expect you to do that, so I'm just going to go to a graph. This looks awfully blurry. Let's see if I can make this look a little better. Get it to... Maybe I have to make that bigger so we can focus on this thing. Okay. Okay, so our graph is going to look something like... That's worse. Let's try one more time. Okay, that's going to be the best we can do. So we've got, if I were to solve this for y, I've got 9x squared equals y cubed. So y is going to equal 9x squared, 9x squared, and I'll put that in parentheses. And I'm going to raise it to the 1/3. Okay. It's going to look something like this. So I'm just going to look at that part of my graph in the XY plane. It doesn't have to be perfect, but just to give you an idea of what this looks like. Okay. So this curve in the XY plane looks like this. Okay, so when we draw this in 3 dimensions, X, Y, Z. Now notice in the positive X, the positive Y, it kind of hugs the Y axis. So it's going to kind of hug the Y axis this way. Okay, we'll just draw the part over here. We're not drawing the entire thing, but we'll just draw the part over here. Revolve this around, it's going to look something like this. The cross section are going to be circles perpendicular to the y-axis. So we're going to get x squared plus z squared. Our equation is x squared plus z squared equals your radius squared. And your radius here has to be a function of y. We're revolving around the y-axis. Okay. So here, in our case, that's going to be the x value of the function that would come out this way. So that's our radius from the center of each of these. Let's draw it here. From each of these circles out in the direction of the x-axis. So the x value would be there. That's our radius all the way around the circle. Okay, so we have to solve this thing for y. So y is going to equal, we need, I'll just write 9x squared. I'm sorry, we don't want that. We want to solve. We need the radius as a function of y, which means the x value is our radius. We have to solve for the x. So x squared equals y cubed over 9, or x equals, we've got the square root of all this. So that's going to be y to the 3 halves over 3. Okay, so that's our radius. So our equation is going to be x squared plus y squared equals our radius, which is y to the 3 halves over 3. But we have to square that. Okay, so our equation is going to be x squared plus y squared equals, when we square that, we'll get a y cubed on the top. We square that and we get over 9. Okay, and that's going to be the equation of our surface of revolution. Stop sharing.